Okay, we're going to do some more word problems. We talk about two cars leave in opposite directions from, let's say, a parking lot. One traveling, and of course this is in the city, at 9 miles per hour. The other at 5 miles per hour. How long before they are 42 miles apart? So once again, you may have to read it more than once, but a diagram might be in order. So they're leaving from a parking lot in opposite directions. And you want to start putting in some information. One is traveling at 9 miles per hour. The other one at 5 miles per hour. And what we don't know is the time. And the time is going to be the same, actually. So this is going to be 9 times the time. And this will be 5 times the time. And we know at the end they're going to be 42 miles apart. So again, thinking of that formula, distance equals rate times time, we just have two sets of distances here. We know the times are the same. One rate is 9, one rate is 5. And that's what we have here. So we're going to add this rate times time plus rate times time to give us distance. So our formula will be 9t plus 5t equals 42. So we group like terms. Divide both sides by the numerical coefficient of our variable. T equals 3 hours. So the answer statement will be how long before they are 42 miles apart? They will be 42 miles apart in 3 hours. And that was how we set it up. In this next one, we have two drivers, Adam and David. Adam, we read, is going at 55 miles per hour, and David is going at 65 miles per hour. Now, Adam, when he left, it was 5 p.m., but he was 10 miles beyond where David was. So at what time will David catch up to Adam? So again, I have it written out here as a word problem, but I'm summarizing it here. So once again, two fellas. Adam is 10 miles ahead at 5 p.m. from where David is. But David's going faster. So we're assuming, since he's going faster, he's going to catch up to Adam. So this amount of distance is the same, and time is the same. So we're going to use the formula distance equals distance. And you recall that distance equals rate times time. So we have rate times time will equal rate times time. Now we know the time is the same. So what will this distance be? Well, this distance is going to be the 10 miles plus his rate times time, which we know is 55 miles per hour. And we have to remember we have this extra distance here, so we're going to have to add these two, because this is distance and this is distance. So, and we're saying this distance equals this distance. So David's distance is going to be 65 times his time. And keep in mind these t's are also the same. So our formula is pretty easy. It's going to be 55t plus 10. This 10 plus this distance is going to equal to 65t. So pretty straightforward. Well, we're going to subtract 55 from both sides, and we get 10t equals 10. And we're going to divide now both sides by the numerical coefficient of the variable, and we get t equals 1. Now, we're not quite finished because they're asking at what time will David catch up? Well, we know it's going to take an hour. He started at 5 p.m. So what will the time be after we add 1 hour to 5 p.m.? Right, it's going to be 6 p.m. So that's the time when David will catch up to Adam. And there's sort of a summary of what we've done. Okay, this is another typical kind of problem where a person would receive this much money, $37,000 in royalty for, let's say, publishing a book. She invests part at 7% in bonds and the rest at 12% in insurance. Now, after a year, she has earned from these investments $3,890. How much did she invest in bonds? Well, we did one like this in the other video, but again, you're going to start with, what's the total investment? Well, it's $37,000. Now, I want to divide this $37,000 into two parts. So the same technique. We're going to say a part of this is X, and the other part is going to be 37,000 minus the X. And that was a method we had featured in the other video as well. So we want to know how much is invested in bonds. So we're going to say let the X be the 7%, and then what's left over is going to be at 12%. So we set up our simple equation. 7% well, 7% of X plus 12% of 37,000 minus X will equal $3,800. $190. And once again, I'm going to suggest that you get rid of the decimals. We're going to add 2 places over here, so that when we get rid of the decimals, this becomes 7x. Get rid of the decimals, this will be 12 times that, which is minus 12x, equals now this. And you don't have to worry about decimal points anymore. So we're going to group our like terms. And we have a negative 12x and a positive 7. This will leave us with a negative 5x. We're going to subtract this big number from this smallest number. So that'll leave us with a negative 55,000. And then we're going to divide both sides by a negative 5. And x equals $11,000 that we invested at the 7%, because that's what we had designated as x. Now, if they wanted to have the other amount, we could have made the other amount the x and the 7% this, but it's much easier designating the unknown as the amount you're looking for, like in this case for bonds. Now, to find out what would be invested, we would subtract 11,000 from this, and that would give us 26,000 at the 12%, which was the insurance. Okay, in this case, we are mixing 3 liters of 4% with 10% to get a 6% solution. So we don't know this amount. We know we have 3 liters of this, so this will be 0.04 times 3 plus 10% of some unknown amount to get a 6%, something sort of in the middle, of this plus 3. Again, get rid of your decimals. And once again, we know we have 3 liters of 4%. We don't know how much of 10%. We have our unknown. And we're going to end up with a 6%, something in the middle, of the n, the unknown amount of 10, and the known amount of 3. So this is 12 plus 10n equals 6n plus 18. We're going to subtract 6n from both sides. That leaves me with 4n. I'm going to subtract 12 from both sides. That leaves me with 6. And n equals 6/4, which is 3/2, which is 1 1/2 liters of 10%, or 1.5, of this particular substance. Okay, well, we'll wrap it up and hopefully you do well.